Welcome to our fifth session on GIS tutorials. In the previous session, we have seen how to change the visualization of the features or shape formation. Today, we will learn some advanced thematic mapping and how to define and change, and update map projection of the displayed map. As we have seen at the last lab session, changing the view can help to analyze data visually without looking into the attribute table and the values of each layer separately. Manipulating the thematic mapping with the attribute data will increase the readability of the map, without hesitation. But before, we will look at the projection system of the project itself and the map. The map projection is the most vital part of any spatial data or a GIS project, since it essentially defines the location of the data, whether it is projected to a 2D surface or it is on a 3D geographic coordinate system. We can mainly divide projections into two distinct groups, namely, the geographic coordinate system and the projected coordinate system. The latter one, as the name implies, is used for the maps in projected space, which is 2D. To see their differences, we are going to change the same map's coordinate system from geographic to projected one. To do that, as always, we are going to use the given map files. Add the UTM shapefile to the workspace. For this purpose, we will let QGIS define or change the projection system of the project on the fly. In this way, we will be able to open any spatial data in their intrinsically defined projection system into a common map projection system on the fly, without changing each layer's information. Defining the correct projection is very important for spatial data and GIS tools, since it can change the accuracy of any calculations and analysis done. In some cases, an incorrect definition cannot even exist in the same space as the projection system, since the embedded data and measurements do not fit with the real Earth locations. Therefore, please be careful about your data and the metadata. Most GIS tools and GIS libraries use EPSG codes as spatial reference system identifiers, SRIDs, and EPSG definition data for identifying coordinate reference systems, projections, and performing transformations between these systems, while some also support SRIDs issued by other organizations. As you can see, the defined coordinate reference system, CRS, is in Geographic 1 and it is already defined for us. If we needed to be specific, the EPSG code is 4326, WGS84 Geographic Coordinate System. Just change the labeling. And observe and analyze the lines. How they are perpendicular and equally spaced over different areas of the world. However, without intrinsically changing the data within the map, if we change the display coordinate reference system from geographic to projected, we will observe a drastic change in the lines and the shape of the map. For this purpose, we can change the project coordinate reference system to ED50 UTM Zone 36 with the EPSG code 23036. As you can see from the map, almost all of the polygons are being distorted considerably. This means that the error on the projection is much higher than the center zone polygon, which is in this case 36. As you can look closely, there is still distortion on the zone 36 polygon, however. When it is compared to the other, it is rather small scale. Now we are going to learn how to use field calculation. If you have defined the projection system accordingly, we are going to automatically populate some of the fields using the field calculator. Now, open up the attribute table of the layer, that is, the layer whose fields are going to be updated. Open up the field calculator by clicking the related icon from the attribute table toolbar. Give an appropriate name for the field. And check the Create New Field option. As for the calculation of the area, write $area expression inside the expression box. Please be sure to change measurement units from default 1 to square kilometers. In order to change that, from the General tab of the Project Properties, change the units area of measurement to square kilometers from the given drop-down. Please be sure that in order to perform this kind of calculation, for example, length and area, projection information must be defined beforehand and accordingly. This will calculate the area in square kilometers. Please update symbology, so that the map display area can be seen distinctively by their colors and numbers as well. As for the third part of this session, we will define and update the projection system of a shapefile. For some cases, the data or the map provided to you does not include or pertains to the right projection information. For example, just upload the given Ankara layer to Workspace. You will see that the city is not located where it is supposed to be. The reason for this is that the defined projection system is false, therefore, it must be changed. From the Layer Properties, select the Source tab. Here write down the EPSG code for the WGS84 Geographic Coordinate System, which is 4326, and apply it. As you can see, the city is being relocated to the current location. For the final part of this lab session, we are going to create a print layout for the current map with necessary map elements, like scale bar and north arrow. From the main menu, select and add a new print layout. A new empty canvas is going to appear on which we will add map and mapping elements, which will definitely increase the readability and understandability of the final progress. Using the toolbar, we are going to add map itself, text, legend, which is very important to convey the necessary information that each element depicted on the map means exactly. Furthermore, scale bar. And lastly, north arrow. First, add a map. Mapping extent can be changed or updated from QGIS map display. If the extent is not what it is expected, please update it using QGIS window or from the item properties. Select interactively edit map extent. For a fine adjustment, you can scroll or with the combination of Ctrl plus scroll to zoom in and out the desired extent. Now add text, write an appropriate title. Add north arrow. Add scale. Change the properties from the item properties if you like. Add legend. Change the symbology again if you like from the item properties. Furthermore, you can also add grids and graticules to the map using the map item properties and add a new grid. Modify the grid. And change X and Y intervals. Add a frame if you like. Finally, if you are happy with the final output, you can export it as an image. From the main menu, choose Layout and Export as an image. Give it a name. Choose the DPI. For better quality, you can increase the DPI value. With this, we wrap the current session. Today, we have seen projection systems and how to change them and, along with creating a nice and easy to interpret map layout. See you next time.